As we just discussed, the quality of k-means clustering is quite sensitive to the initialization status. Okay. Then we need to see how to do good initialization so we find a good quality clustering using k-means method. I just give you a simple example. You can see different initialization may generate rather different clustering results. Okay. Some may not be optimal at all. Just give you an example. Suppose we have only 4 points, we will find 2 clusters. Okay. If we initialize in this solid circle, that means these 2 points get into one cluster. Like if we give you the center like this 2, they will attract these 2 and these 2 as in one cluster. Then actually it becomes stabilized because you calculate the center is still here. They will not move. So then you find a pretty ugly cluster because you see these, if you vertically group things into 2 clusters, the sum of the square distance, or SSE, actually become rather small. From this point of view, we know the quality of the clustering could be very sensitive to the initialization. Originally, McQueen in 1967 said we should select the k-seeds randomly. Then we need to run this algorithm multiple times using different seeds. In some software package, they may even say run these algorithms like 200 times. Finally find out which one you derive the best k-means cluster. Simply says you want to find the SSE, the sum of the square error, is minimized. There are many other methods also proposed for better initialization. For example, there's one called k-means++ proposed in 2007. Essentially, this plus initialization is as follows. Okay. The first centroid you can select randomly. But then the next centroid to be selected, you try to find the farthest point from the current selected points. Okay. That means the selection, then you based on weighted probability score, you based on different probability, you select which is the best for the next one. Okay. Then this selection continues until all the k centroids are obtained. That's initialization is done. Then we can run the k-means algorithm. Okay. Now I'll give you a simple example. You can see poor initialization may lead to some poor clustering. For example, we take the same data sets, those black points, as we shown before. Now we give you 2 centroids initialized as the red ones here, the blue ones here. Okay. With this initialization, we can get, like clusters. We can assign these objects into 2 different clusters in different colors. Okay, one, the upper part, those points assigned to the red cluster. The lower part is assigned to the blue cluster. Then we can recalculate the center again. You can see the center actually moved. Then with this recalculation, we can reassign those points. You can run this a few rounds. You probably can see finally they stable like this, but actually this is not a very good cluster at all. Okay. So that means this round of the k-means generates some poor quality clustering. That simply gives us a simple show we do need some smart initialization or multiple random initialization, then we select the best ones. Okay. So this is the initialization of k-means clustering.